Yesterday, in the intro to systems of equations, we talked about the three different types of solutions. That there was a one solution where there was exactly one ordered pair that happened to be the intersection of the two lines. We talked about infinite solutions where the lines were actually on top of one another, to where every point on that line was a solution to that system. And we talked about no solution, where when we graphed the lines, we ended up with parallel lines. All of those involved graphing to solve. Today we're going to look at one method, substitution, which is used to, it's an algebraic means to find the exact solution to a system of equations. It's not the only method, but it's a method we're going to look at first. The steps to solve by substitution are relatively simple if we follow through step by step. The first step is, when necessary, solve one of the equations for either x or y. Okay, some of the systems already has one where x is isolated or y is isolated, and in that case you're ready to go on to step two. Step two says that we're going to substitute the resulting expression from step one. So that means if we solve for x, okay, we're going to take that term and we're going to plug it into the other equation to replace the variable. So if we solve for x, we're going to take whatever x equals and replace x with it in our second equation. And then we're going to solve the equation for the other variable. The next step would be to take the solution that we found, the value that we found in step two, and substitute it into either equation, okay, and solve it for the other variable. The solution will be, we're going to end up with an ordered pair, or we're going to end up with infinite solutions or no solution. So I'll give you a minute to get those written down, and then let's work a few examples, try to make sense of this. Here's our first example, and in this one, if we notice, step one is already done for us. This one has already been solved for y. So we're going to take 2x plus 1 and replace y in this equation. So we're going to start out by 3x plus, instead of y, we're going to plug in 2x plus 1 equals negative 9. We're just going to go ahead and solve this for x. Our first step is going to be to combine our like terms here. So we have 5x plus 1 is equal to negative 9. Next step to isolate x would be to undo the addition, which we'd subtract 1 from both sides. The result would be 5x is equal to negative 10. To undo 5 times x, we're going to divide both sides by 5, and we end up with x is equal to negative 2. So in our solution, we know, in our ordered pair, we know that x is negative 2. Now we take this and we can plug it into either one of these equations here. Which one would be the easiest to plug it into? Yeah, I think it would be this one. So we're just going to take it and say y is equal to 2 times, we're going to plug in negative 2 plus 1. We need to go ahead and do the multiplication first. So we're going to have y is equal to negative 4 plus 1. So y is equal to negative 3. So the other term in our ordered pair would be negative 3. So our solution is negative 2, negative 3. To check it, I can plug it into my equations and see if it makes sense. So in this case, it would say negative 3 is equal to 2 times negative 2 plus 1. Well, 2 times negative 2 is negative 4, plus 1 is negative 3. It works there. So let's take a look at it here. We would do 3 times negative 2 plus a negative 3 is equal to negative 9. 2 times negative 3 is negative 6, plus a negative 3 would be negative 9, and negative 9 equals negative 9. So our solution would be true. Let's try another example, and this time we're going to have to isolate one of the variables. And in looking at these two equations, to me, the easiest one to do would be to isolate x in this top equation. So let's go ahead and move this one out of the way for now so we can do our work. First thing to do here would be to subtract 2y from both sides. That leaves me with x is equal to negative 2y plus 6. Now that I have x isolated, I can plug this information in for x in my equation. So let's do 3 times negative 2y plus 6 minus 4y is equal to 28. Let's go ahead and open those parentheses using the distributive property. So 3 times negative 2 would be negative 6, so that's negative 6y. 3 times 6 is 18, so that would be plus 18. Then we have minus 4y is equal to 28. Our next step would be to combine our like terms. We have a negative 6y there and a negative 4y. We combine them for a negative 10y plus 18 is equal to 28. Next we need to undo the addition, so we're going to subtract 18 from both sides. Subtracting 18 from both sides will leave us with negative 10y is equal to 10. Our last step on isolating y would be to divide by negative 10. Working on this one, we'll end up with y is equal to negative 1. So in our ordered pair, we know that y is equal to negative 1. Our next step would be to take negative 1 and plug it into either one of these. So let's go ahead and plug it into our original, the first one we worked with. And let's just say that x plus 2 times negative 1 is equal to 6, excuse me, kind of zoned out there. So here we would go ahead and do the multiplication. So we have x plus a negative 2y is equal to 6. Since we know plus a negative is the same thing as subtracting a positive, to get rid of that, we need to add 2 to both sides. So we're going to add a positive 2 to both sides. And we end up with x is equal to 8. So we know that our value of x in our ordered pair is 8. So our solution to this would be 8, negative 1. If we want to check our solution, we need to plug it in. And as we plug it in, I plug in 8 here, plus 2 times negative 1 is equal to 6. Well, 8 plus 2 times negative 1 is a negative 2, is equal to 6. 8 plus a negative 2 is 6, so we have 6 is equal to 6. Over here, when we plug it in, we would have 3 times 8 minus 4 times negative 1 is equal to 28. 3 times 8 is 24. Negative 4 times a negative 1 is a positive 4 is equal to 28. 24 plus 4, 28. So we have 28 is equal to 28. So our solution holds. Okay? Let's look at a couple of special circumstances. So on this first one here, we've already got one equation solved for y. So let's just go ahead and take our equation, our term here, and plug it in for y, which is going to leave us with negative 6 times x, and then it would be plus 3 times 2x minus 4, 2x minus 4 is equal to negative 12. Excuse me. Okay. From here, we can go ahead and open the parentheses, which would be 3 times 2 is 6, so that'd be 6x. And 3 times negative 4 would be negative 12. And over here, go ahead and bring down what we haven't used. We need to combine our like terms. Well, our like terms, we have a negative 6x and a positive 6x. When we combine those, we have 0x. Well, 0 times x is 0, so we basically have negative 12 is equal to negative 12. What does that mean? Do you remember what that means? Absolutely. On this one, it would be infinite solutions. Okay. Next example I want to look at is this one right here. And again, we already have one of them solved for a variable. So on this one, we can take 2x minus 3 and plug it in for y in this equation. So if I take this, I've got 2x minus, in parentheses, I'm going to go ahead and put 2x minus 3 is equal to 8. So remember, to open this parenthesis, we've got a ghost of 1 standing here. So we're going to multiply everything in there by a negative 1. What that does is negative 1 times 2x makes it a negative 2x. Negative 1 times a negative 3 makes it a positive 3 is equal to 8. Next step would be to combine like terms. There's our two like terms. 2x plus a negative 2x is 0x, and we know 0 times x is 0. So we've got 0 plus 3, which is 3. And on the other side, we have 8. Is that a true statement? Of course not. Okay, so we know on this one, we have no solution. I hope this explains one way other than graphing to solve systems of equations. Let me know if you have any trouble working on this, and that's a wrap.